Hi everyone, today we'll be looking at the GCSE 91 November 2020 paper 2 paper. That's a calculator paper of the higher tier. Question 1 is about writing 84 as a product of its prime factors, and I could start by dividing 84 by prime numbers until I get to 1. So I start with 2, 84 over 2 is 42, again by 2 giving me 21, then 3, 7, and 7, 1. So that means I can write 84 as 2 squared times 3 times 7. Now to find the lowest common multiple of 60 and 84, I'm going to repeat the process for 60. So I'm just going to say that 60, I will divide by 2, getting 30, again 2, 15, 3, 5, 5, 1. So 60 is 2 squared times 3 times 5. And we said that 84 is 2 squared times 3 times 7. And we know that when we are looking for the LCM, I take all the prime factors to the highest power. So the LCM should be 2 squared times 3 times 5 times 7. And this is giving me a result of 420. Question 2, we've got a Venn diagram to be completed. The universal set consists of the positive integers up to and including 10. In set A, we've got the even numbers, and in set B, it's the factors of 10. We know that 2 and 10 are common to both sets, so they will appear in the intersection of A and B. The remaining even numbers are 4, 6, 8, and the factors of 10 are 1, 2, 5, and 10. I still need to complete the rest of the members of the universal set that will appear outside A and B, and this should be 3, 7, and 9. A number is chosen at random from the universal set, and what's the probability that we are in A intersection B? Remember that A intersection B means and, so I want to be both in A and B, so it's obviously these two numbers out of a total of 10 possible numbers, so the answer is 2 out of 10, which simplifies to 1 over 5. Number 3, Carlo puts teens into small boxes and into large boxes. He's putting 6 teens into each small box, and he puts 20 teens into each large box. Now he puts a total of 3,000 teens into the boxes, so that the number of teens in small boxes to the number of teens in large boxes is 2 to 3, and then claims that less than 30% of the boxes filled with teens are large boxes. We need to determine whether Carlo is correct, and obviously we need to supply all the necessary working to justify our answers. So I will start by considering the 2 to 3 ratio given here. Now 2 plus 3 is 5, which means that 2/5 of the 3,000 teens are in small boxes. So 2/5 times 3,000, which is equal to 1,200. That's teens in small boxes. So if we've got 1,200 teens in small boxes, and we'll be putting 6 teens into each small box, I will do 1,200 over 6, which means I've got 200 small boxes. I will repeat the same process for large boxes. I will start by saying 3/5 of 3,000, which is 1,800, is the number of teens in large boxes. And Carlo has been putting 20 teens into each large box. So if I do 1,800 over 20, I get 90 large boxes. This means I've got a total of 290 boxes. And 90 of these are large boxes. So 90 over 290 times 100 to turn it into a percentage. And I get an answer of 31.0%, which is greater than 30%, which was the claim that Carlos said that it's less than 30% the boxes filled with tins are large boxes. So 31% is greater than 30%, and therefore Carlo is wrong. It's crucial to write explicitly that he is wrong, but also to supply the working to justify our answer. In number 4, we need to complete the table of values for y is 5 minus x cubed. So we can just put this on the calculator. We get the values of 13, 5, 4, and minus 3. And we need to plot the points and join them with a smooth curve. So it's minus 2, 13. It's minus 1, 6. It's 0, 5, 1, 4, and 2, minus 3. I will join them with a smooth curve, which will look something like this. To score the 2 marks. Number 5, we need to work out the value of x. This is right angle trigonometry here. We've got the opposite and the hypotenuse. I should be using sine. Sine of 34 is x over 178. So 178 sine of 34 is x. I put this on the calculator and I get that x is 99.5 millimeters. Notice I've been asked to give my answer to 1 dp, so I've got an accuracy to stick to. 6. Vector A is 3, 4. Vector B is 5 minus 2. I need to find 2A minus 3B as a column vector. Remember that when we multiply vectors by scalars, we multiply both entries. So in this case, what I have is 2 times 3, which is 6, minus 3 times 5, which is 15. So 6 minus 15 is negative 9. And then for the bottom entry is 2 times 4 is 8. And minus 3 times minus 2 is 6. So 8 plus 6 is 14. So my answer is negative 9, 14. Question 7, we've got a right angle triangle and a quarter circle. We need to work out the area of the quarter circle here. So obviously I need BC here because that's the radius, and I'm going to use Pythagoras theorem in triangle ABC to do that. So I'm going to say that BC squared is hypotenuse squared minus the AB squared. So we get that BC is the square root of 81 minus 36, which my calculator gives me as 3 root 5. And then area of quarter circle will simply be a quarter of the area of a circle having a radius of 3 root 5. So we know that the formula for the area of a circle is pi r squared. So I'm going to do pi r squared over 4. And in the place of r, I'm substituting 3 root 5. I plug everything on the calculator as it stands, and I get the result of 35.3 squared meters. Number 8, we've got Tariq who buys a laptop. He gets a discount of 5% off the normal price, and he ends up paying 551 for the laptop. We need to work out the normal price. Now, the normal price will be deducted 5%. So if I want to decrease a quantity by 5%, the multiplying factor is 0.95 because I end up paying 95% of the original. And we ended up paying 551 pounds. So to get the normal price, I'm just gonna do 551 over 0.95, which my calculator gives us 580 pounds. Joanne invests 6,000 in a savings account, which pays compound interest of 2.4% for the first year and 1.7% for each extra year. We need to work out the value of the investment after 3 years. So we start off with 6,000. Over the first year, they increase by 2.4%, which means that the multiplying factor is 1.024. And then for the next 2 years, the increase is 1.7%. So it's going to be 1.017 squared because this is applied for 2 years. And we get an answer of 6,354.67. Notice that we haven't been asked for a particular degree of accuracy here, but since this involves money, I will be giving my answer to 2 decimal places. So 6,354.67 pounds. Number 9 is Aisha, who has recorded the height in centimeters of some girls. This is some information given here. And she then went on to draw the box plot shown here, but it's not fully correct. We need to identify 2 things that she did wrong. So if we look at the box plot and compare with the numbers shown here, the first thing we notice is that the upper quartile, Q3, according to the table here, should have been 154 plus 17. So reminder that the interquartile range is Q3 minus Q1. So knowing the interquartile range and the lower quartile Q1 means I can calculate Q3. And that's 171. But if you notice here, this is Q3 and it's actually 172. So I'm gonna make a note here that Q3 should be at 171, not 172. And then the median, 162 centimeters, notice that it's at 161. The median is the middle of the box. So we're gonna say median should be at 162, not 161. Number 10, simplify 1 over m squared to the power of 0. Anything to the power of 0 is just 1. And then in B, we need to simplify this. I'm not going to expand the denominator. That will make things a lot worse. I'm actually going to simplify or think of this as 8 brackets x minus 4 over x minus 4x minus 4. So the x minus 4 simplifies and I'm left with 8 over x minus 4. In C, we need to simplify this. It's 3n to the power of 4, w squared, all to the power of 3. So it's going to be 3 cubed n to the power of 12, because when I raise a power to a power, I multiply the indices together. W to the power of 6 for exactly the same reason. 3 to the power of 3 is not 9. That's a common mistake. It's 3 times 3 times 3, which is 27 n to the power of 12 w to the 6. We've got Jack in a restaurant. We've got 5 starters, 8 main course, and some desserts on the menu. He's gonna choose 1 starter, 1 main and 1 dessert, and he claims that there are 240 ways that he can choose his starter, his main course, and his dessert. So we need to assess on whether Jack could be correct. So we've got starters, we've got main, we've got desserts. We've got 5 choices for starters, 8 for main, and say n for desserts. The total number of combinations is claimed to be 240, and to find the total number of combinations, I multiply these together. So 5 times 8 is 40, so 40n is 240, and n is 6. Now, because n turned out to be an integer, it means that Jack could indeed be correct. So I'm just going to state this. Since n is an integer, Jack could indeed be correct. We would be certain that he was wrong if n turned out to be a non-integer, because we know that the number of desserts is certainly an integer, a positive integer. Number 12, we've got the graph of the volume v liters of petrol in the tank of a car after traveling a distance of d kilometers. We need to work out the gradient of the graph. So I'm going to pick 2 points. Obviously, I'm going to go for this one, which is 0.27. And I will also pick the 300,0. We know that the gradient of a straight line passing through 2 points with coordinates x1, y1, and x2, y2 respectively is given by y2 minus y1 over x2 minus x1, which in our case is 0 minus 27 over 300 minus 0, which is minus 9 over 100. We saw that the line was going downhill, so it's expected to get a negative gradient here. Interpret what the gradient of the graph represents. So we've got the volume against the distance. For every 100 that I go to the right, I go 9 down. So this means that for every 100 kilometers covered, the volume of petrol in the tank will drop by 9 liters. It's this decrease, the negative gradient, that's the drop. And for every 100 we go to the right, we go 9 down. So for every 100 kilometers covered, the volume will go down by 9 liters. 13, it's a triangle ABC. We need to work out the length of AB. Obviously, it's not a right angle triangle, but I have the 2 angles here, and I can actually start off by finding angle A, which is 180 minus 34 plus 26, which turns out to be 120. Now I've got the 3 angles. I've got one of the sides, BC. I need to work out AB. So I'm going to use the sine rule. I'm going to say that sine of 120 over 23.8 is equal to sine of 34 over AB. I will cross multiply, getting AB sine 120 is 23.8 sine of 34. So AB will be 23.8 sine of 34 over sine of 120, which gives an answer of 15.4 centimeters. We've got 2 squares, A and B. The length of each side of B is 4 centimeters greater than the length of each side of A. The area of B is 70 squared centimeters greater than the area of square A. We need to find the area of square B. So I will start off by letting the side of A be x, and the fact that the length of each side of square B is 4 more than the square A means that this is x plus 4. Now the area of B is x plus 4 all squared, is 70 squared centimeters greater than the area of A. The area of A is x squared, so it's x squared plus 70. The challenge here is obviously to write out the equation. And then I will expand the left-hand side. It's x squared plus 8x plus 16 equals to x squared plus 70. The x squareds go away, so 8x is equal to 54, which means that x is 54 over 8, which is equal to 6.75. Now I need to find the area of square B. So x plus 4 is the side of square B, which is 6.75 plus 4, leading to 10.75. So area of B will simply be 10.75 all squared, which gives an answer of 116 squared centimeters to 3 SF. We are given this triangle A and B, and we need to describe fully the single transformation that maps A onto B. So looking at it, the first thing I observe is that the size has changed, and so it's obviously an enlargement. I also see that the orientation has changed, so it's a negative enlargement. I will start by joining corresponding points. So this point here goes here. So if I join it together with a straight line, this is what I get. And then this point over here will go here. So if I join them together, I get this. And I could actually do the same for the third vertex here, goes here. And if I join it together, I get that. So it's obvious that my center of the enlargement is this point here. I need to determine the scale factor. We can remind you that the scale factor is simply image over object. We are looking at the transformation of A onto B. So A is the object, B is the image. And I'm gonna take one dimension, one side. I know that this here is 2, and it goes here, becomes 3. So it's 3 over 2. But because of the change in the orientation that we originally mentioned, it's a negative scale factor. So overall, this is an enlargement with center 1, 1 and scale factor minus 3 over 2. We've got the first 5 terms of a quadratic sequence, and we need to find an expression for the nth term of this sequence. So we know that for quadratic sequences, the second row of differences should be constant. So I start by writing out 10, 21, 38, 61, 90. The first row of differences is 11, 17, 23, 29, and the second row of differences is 6, 6, 6. So constant, and the value in the second row of differences is constant. We know that a quadratic sequence would look something like this: an squared plus bn plus c. And we know that the number we obtain here, the constant difference in the second row, is is related to A. So if I take this and divide by 2, I find A. So A is 6 over 2, which is 3. So I could start by writing out 3n squared here. So this is the first term, the second term, the third term, the fourth term, the fifth term. So when n is 1, 3n squared is 3. When n is 2, 3n squared is 3 times 2 squared, which is 12. When n is 3, 3 times 3 squared is 27. When n is 4, 3 times 4 squared is 48. And when n is 5, 3 times 5 squared is 75. So if I include the 3n squared term, it means that I have already got these numbers here. So from 3, I need another 7 to go to 10. From 12, I need another 9 to go to 21. From 27 to 38 is 11. From 48 to 61 is 13. And from 75 to 90 is another 15. So this now is an arithmetic sequence with first term 7 and common difference 2. So we know that the nth term of this sequence is a plus n minus 1d, which is 7 plus n minus 1 times 2, which if I expand, I get 7 plus 2n minus 2, which is 5 plus 2n. Altogether, this means that the 3n squared with the 5 plus 2n will group together to give me the nth term of the quadratic sequence. So my answer should be 3n squared plus 2n plus 5. 17, write down the coordinates of the turning point on the graph. The fact that the prompt is to write down, not to calculate or determine, it means that it has to be something obvious. Don't go about expanding. They gave us the expression for y in this form to help us. So we know that x plus 12 squared will be greater than or equal to 0 always for all values of x. So if I deduct 7, this will always be greater than or equal to minus 7. And this minimum will be attained when this is 0. So at x is minus 12, y will be minus 7. And these are the coordinates of the turning point. 18, we're being given a solid cone. Base diameter is 20 centimeters and slant height is 25 centimeters. And then we draw a circle around the surface of the cone at the slant height of 10 centimeters above the base. And we paint gray the curved surface of the cone above the circle. We need to work out the area which is not painted gray. We need to work out the area over here. So, and it's the curved surface, not the base. So we need to start off by visualizing this as one big cone and then another smaller cone. If I drop the perpendicular here, what I will observe is that we are looking at similar triangles. This here is 10 and this here is 25 centimeters. So I can call the radius of the smaller cone x, and obviously the slant height here is 15. So by similar triangles, I could set up a ratio. The ratio of the slant heights, so 15 over 25, is equal to the ratio of the radii, x over 10. So if I cross multiply, I get 150 is 25x, so x is 6. So we've got the radius of the smaller cone. So the area that is not painted gray is simply the curved surface area of the big cone, take away the curved surface area of the smaller cone. So the area we're after will be pi times r times slant height minus pi times the radius of the smaller cone times the slant height of the smaller cone. We need to give answers as a multiple of pi. So this is 250 pi minus 90 pi, which is 160 pi. It's a hot air balloon that's descending. The height of the balloon n minutes after the start of the descent is given by h subscript n meters. The height of the balloon n plus 1 minutes after it starts to descend, h n plus 1 meters, is given by this relationship here, with k being a constant. So the balloon starts to descend from a height of 1200 meters at 9:15. And at 9:16, the height of the balloon is 1040 meters. We need to work out the height of the balloon at 9:18. So I need first of all to find a way to connect the times with the value of n. So I will start by creating a table. It's the time and n. And we know that the descent started at 9:15. So at 9:15, we are at 0 minutes after starting to descend. Then at 9:16, n is 1. At 9:17, n is 2. And at 9:18, n is 3. So we've been told that the height is originally 1200. So we know this is h0, and at 9:16, h1 is 1040. So from this recurrence relationship that's been provided by the question itself, if I set n to be 0, I get that h1 is k times h0 plus 20. So 1040 will be 1200k plus 20. So 1020 is 1200k, which means that k turns out to be 1020 over 1200, which is 0.85. Now, I will apply the same technique with n is 1, and I will get that h2 is k, which is 0.85, as we found, h1 plus 20, which is 0.85 times 1040, the value of h1, plus 20, which my calculator gives us 904. So I now know that this is 904, and I will go through the whole process once more to get h3. So when n is 2, h3 is 0.85 h2 plus 20, which is 0.85 times 904 plus 20, which gives an answer of 788.4 meters. So this is the height at 9:18 as requested by the question. Question 20, we've got the red sweets and yellow sweets in the back. We've got n red sweets and 8 yellow sweets, and Sajid will take a sweet at random and eat it. he claims that the probability will be red is 7 out of 10, and we need to show why this cannot be the case. So I will start off by saying that the total number of sweets is n plus 8, the number of red sweets plus the number of yellow sweets. The probability that we take a red sweet will be the number of red sweets n over n plus 8, and Sajid claims that this is 7 over 10. I will cross multiply 10n is 7 brackets n plus 8. So 10n is 7n plus 56, leading to 3n being 56. So n is 56 over 3, which is 18 and a third. This is not an integer. We can have a non-integer number of red sweets. So this means that Sajid is wrong. The probability cannot be 7 over 10. So we need a good explanation here to justify our conclusion. Now, after Sajid has taken the first sweet and eaten it, he's gonna take at random a second sweet, and the probability that both the sweets he takes will be red is 3 over 5. We need to work out the number of red sweets in the bag. Now, the number of red sweets originally was n, and the total was n plus 8. And if I took a red sweet, it means I'm now left with n minus 1 red sweets out of a total of n plus 7 sweets. So, because I want both of these to happen, this times that will be 3 over 5. So, I will start by taking care of the left-hand side. I do numerator with numerator, n squared minus n, over denominator times denominator, n squared plus 7n plus 8n plus 56. This is equal to 3 over 5. I will cross multiply 5n squared minus 5n is equal to 3 times, and this is n squared plus 15n, the 7n and the 8n, plus 56. I will expand 5n squared minus 5n is 3n squared plus 45n plus 168. I will collect everything on the left hand side to give me 2n squared minus 50n minus 168. All of them are even numbers, so I'll divide by 2 to make the numbers a bit smaller. N squared minus 25n minus 84. I know that I expect at least one of the solutions to be an integer, and I could try factorization, or I could use the quadratic formula. Now 84 is 28 times 3, so I can actually factorize this into n minus 28 n plus 3, which means that n minus 28 is 0, or n plus 3 is 0. So n is 28, or n is minus 3. Obviously, we can have a negative answer here, reject, not valid. So the number of red sweets n is 28. In question 21, we begin the graph of f of x, and we need to sketch f of minus x. Now the negative sign here means that all the x values get multiplied by minus 1. So whatever you see at minus 4 will go to 4. Whatever you see at minus 2 will go to 2. So obviously this is a reflection about the y-axis. Now, it makes sense to start by identifying the points where they will go to. So the 0, 0 will remain there. The minus 1, 2 will go to 1, 2. The cut at minus 3 will go at 3. This will be here, and we've got another here. So it's going to be something like this. A reflection about the y-axis. And then B, we are being given two curves, C and S. We know that C has the equation 5 plus 2x minus x squared, and it's being transformed by translation to give curve S such that the point 1, 6 gets mapped to 4, 6. So obviously we are looking at a translation 3 units to the right. Now it makes sense to start by saying that curve C has equation f of x is 5 plus 2x minus x squared, and then curve S will simply be a translation 3 to the right, which is f of x minus 3. Now this means that wherever I had an x, I now replace it with x minus 3, so this will be 5 plus 2 brackets x minus 3 minus x minus 3 squared. And there is no need to expand this. We haven't been told to give it in a particular form. So this is where we can stop as the final answer. Question 22 sees a circle centered at the origin. We've got a tangent passing through these 2 points, and we need to work out an equation of C showing all working. Well, I'll start by reminding you that the circle centered at alpha beta pass with the radius r has equation x minus alpha squared plus y minus beta squared equals r squared. I will quickly draw this. We've got a circle, it's centered at the origin, so it looks something like this. And we've been told that there is a tangent which cuts at minus 20 and 10. Maybe it's something like this. So this is 10, this is minus 20. And I notice that we've got the radius here, which, taking into account the fact that it's a tangent, it means that this is a right angle here. So the idea is the following. We know that this being centered at the origin, alpha is 0 and beta is 0. We've got the center. We are only looking for r. So I'm thinking of trying to determine the area of this triangle in 2 different ways. So one way is just to do base 20 times height over 2, and the other will be to do this as the base times the height of r times 2. So I will call this distance here x. So I could extract the triangle. This is 20, this is 10, this is x, this is the right angle. So by Pythagoras, we've got that x squared is 10 squared plus 20 squared. So x squared is 500. X is the square root of 500, which turns out to be 10 root 5. So now that I've got this here, I'm gonna say that the area of the triangle is 20 times 10 over 2, or x 10 root 5 times r over 2. The 20 times 10 over 2 is simply 100, and the 10 root 5 over 2 is 5 root 5. So 100 over 5 root 5 is r. And I can actually square this. R squared is 100 over 5 root 5 squared, which turns out to be 80. I square because we said that the equation of the circle involves r squared. So the equation of C will simply be x squared plus y squared is equal to 80. So the key point here was to approach this by looking at the area of the triangle and calculating in two different ways. Base of 20 times height of 10 over 2, or base of x times height of r over 2. And that's it.